Hello everybody, so today we'll talk about the system design of Facebook's live comment feature. So in the Facebook, user can stream the video and audience can post something like, oh, this is funny or something. Yeah. And it is streamed and other users can see the posts from other users. So yeah, so upper half of the smartphone display, the video is going on, and in the bottom half, the commenter streaming, like scrolling up or down, so up or down. So that's something happens in the Facebook Live comment feature. And in this video, I will focus on the feature of the live comment itself. So I don't talk about how live video is working or something like that. Okay, so that being said, I will start with the function requirement. So because I will focus on the live comment feature only, so the function requirement is quite simple. So first we can say user should be able to post the comment. And for the user should be able to view the comments from other users or himself. And also user can, okay, so when user opens the live video, obviously, if it in the middle of the video, he should be able to see the comment before he joins the video. He opens the video. So I would include this in the function requirement. The user can view comments before he joins. Opens the video. Okay. And I will include something here. User can view comment in real time. Okay, so this is a function requirement. So next, I will do the define the non-function requirement. So I will start with the cap theorem. So in cap theorem, the system can support up to 2 of 3. Consistency, which is strong consistency, and availability and partition tolerance. Because we are developing the distributed system, partition tolerance is a must. Otherwise, the system cannot handle the network loss, which is the isolation, which is a separation between the nodes, servers. So P is the must. So the problem is which we should take, consistency or availability. So I can rephrase this. If I take the consistency, user can always see the latest comment from other users or himself. But if it is not possible, the system doesn't return any comments. But if I take the availability, system always returns the comments, but it may not include the latest comments by users. So this is a comparison between consistency versus availability. And in this Facebook Live comment, I definitely go with the availability over consistency. Because from the user experience perspective. So for the user, even if the latest comment is not available for, let's say, 100 sec or 200 millisec, it's totally fine. Yeah. Rather, he should be able to see the comment always, even if the latest one is not included. So that's why I choose availability over consistency. Okay. And also, I would to include low latency in the non-function requirement. So user can post comment, view comment, let's say it should be less than 200 millisec. So post and real time. So of course, real time is now, even for real time, we have to define the latency. So real time view, this should be less than 200 millisecond. And also this, I would call it bulk view. All of them should be less than 200 millisecond, which, so with 200 millisecond, user feels that it's almost real time, almost immediate, and also he doesn't feel that he's waiting for something. So I think 200 millisecond is a good sweet spot. And maybe I should clarify something here. So what I say by consistency here is the exact time when the API is returned from the server. Yeah. But for this latency, I'm defining the user experience. So user should be able to post something, and then in 200 millisecond, it accepted. Yeah. And for real-time view, okay, so for this one, I would say this is the time from some user post a comment, and then that comment is viewable from other users. So that, I would say 2 hops latency total should be less than 200 millisecond. Yeah. So yeah, that's something I wanted to clarify here. I mean, this consistency is the kind of concept about the data to be returned from the system, but for this one, low latency is something I define for user experience. Yeah, so maybe I should separate this quickly. So there should be low latency in real time streaming. User to user. Okay. Okay, so I will talk about the scalability also. So this should be, the system should be scalable to 1 million, more than 1 million users, or I should say concurrent viewers, and also 1K, more than 1K comment per sec per video. Sorry, comment per sec per video. So both of these numbers, concurrent viewers and comment per sec, are per video. Okay. Okay, so now we'll talk about the core entities. Core entities are like the database tables, table names. So in this video, I can say user, and also user watches the video and user makes the comment. Yeah, so those are the core entities. Okay, so now I will talk about the APIs. So firstly, I will list all the names of the APIs first. So we need, from the first function requirement, we need the create comment API. From the second API, we need the fetch real-time comment API. And from the third function requirement, we need to bulk fetch the comment. So bulk fetch comment API. Okay. So I will talk about the details of each API. So for this one, create comment API, I use the post API because post is used for the creation. And of course, the comment is associated with the video, so I nested in the videos slash video ID. Then I include it in the comment. Yeah. And what I can do is, of course, we need the command to be posted. And it should return 200 false status, which is creation succeeded, and it returns nothing. Sorry, 201. So 201 HTTP status, it means the request succeeded and the resource is created, but there's nothing to be returned. Okay, and one thing I'd like to discuss here is if we need the authentication. So if we need the authentication, what I would do is include the session token in the header so that the backend API can do the authentication. And in the case of Facebook, Facebook itself is the application which requires the authentication. So I can say we need the auth token in the header. Yeah. So this is a session token. So no backend can do the authentication. And next one, fetch real-time comment. So this is something tricky, and I have something to discuss here. So should I use the HTTP request here to short polling it? So when it comes to the real-time data update, we have three options. So number one, HTTP short polling. Number two, SSE, server side sent event. This is actually HTTP. And also we have WebSocket. So I will compare these and I'd like to go which I should take. So firstly, HTTP short polling is something like, let's say the client makes a request, this time every 200 millisecond, and fetches the record from database, from the backend. So because our real-time comments latency should be less than 200 millisecond, at least the client has to do the short polling every 200 millisecond. And what happens is that server is quite heavy loaded if each viewer makes a short polling every 200 millisecond, especially when the system is scaled out. So for that scalability issue, I don't choose HTTP short polling. And HTTP SSE, server sent event, is something like the something like this. So client makes the HTTP request, and that HTTP connection is kept alive for maybe 30 seconds or something. And in that period, if there is a message sent from server to client, that is sent on this connection. But the server cannot send any message. So it's unidirectional from server to client. But for WebSocket, this is bidirectional. So the connection is kept, and server can send the event to client, and also client can send events to server can send event to client too. So this is bidirectional. And when I compare these two, I would go with HTTP SSE. So this is because in the use case of Facebook Live comments, the user comments, while the user make one comment, there are so many comments coming back from server. So even if this is by strict definition, this is bidirectional. It's not balanced. So what I can do is, and actually I already created this API. So by using this create comment API separately, now what the client has to do is fetching the client in real time, only one direction. Yeah. So because of the low frequency of making commands, creating commands, I use HTTP SSE. Okay. And for WebSocket, this is for bidirectional, especially when the message is sent from in each direction are balanced. But so this is not the case for this Facebook Live comments. And also this WebSocket requires the setting up the WebSocket infrastructure. So this is different from HTTP. It uses TCP, but it switches to a WebSocket. So we need the kind of special infrastructure specifically for this. So considering the cost, I would go with HTTP SSE. Okay. So for this one, I would say get. I would define this API and header of token. This is the same. And there's nothing from server, nothing from client, but it returns comment. So this is what happens here. Okay, and number 3, bulk fetch comment. So this is quite normal HTTP request. And we need to specify the range of the comment to be fetched. So I can say, so here I have a discussion if we should use the page-based, cursor-based pagination or offset-based pagination. So offset-based pagination is something like specifies the kind of offset, which should be the comment sequence number in the video and number of comment to be fetched, like 100. But for cursor-based pagination, server completely has the kind of control on the range of the comment to be returned. And internally, cursor should typically mean the timestamp range. Yeah. So now the client specifies the cursor, which internally means the timestamp from and the number of comments to be fetched. So the good point about this cursor-based pagination is, let's say we use the B-tree for the comments. With putting the B-tree index on the timestamp, the server side can access the data, the first comment to be returned in login time and linear scan the next, let's say 100 comment and return it. But for the offset pagination, what it does is, even if the first number, sequence number is specified, the server has to, in the server side, in the database engine has to go to the offset by linear scan. So it takes overwhelming time, yeah, to access the first comment. So performance-wise, cursor-based pagination is better, and I'd like to use cursor-based pagination here. For the client side, in the front end, we can use the scrolling kind of comment like the feed. Yeah. So in that way, we cannot suppose the conventional paging, like clicking page 1, page 2, page 3, and jumping to page 3 or something. But performance-wise, this is better, cursor-based is better, and this, in this Facebook Live comment, the comment should be streamed, like the, yeah, it should be streamed, so cursor-based pagination completely works. So I can say start. Okay, so for this one, we specify cursor here and size. Okay. Yep, so this is something I can do. So from this cursor position in backward in the time, this number of comment returned from the backend API. Okay, so these are APIs. Okay, so now we talk about the high-level design of the system. So in firstly, I try to meet all the function requirements first without considering the quality, I mean non-function requirements satisfaction. And after that, I will update the design to meet all the non-function requirements. So in this Facebook Live comments, there are two types of users. So I intentionally separate them. So one is user who makes a comment. I say post user. And let's say the other is viewer user, reader user. Of course, poster user should be able to read his comment, but for the convenience of the explanation, I separated them here. So I put the API gateway because we will go with the microservice design. So the reason is, in the end, we have to scale so much, like this number. So I would go with the microservice architecture and make sure that firstly, we can separate the domain, and each domain should be handled by each engineering team. So I mean, the separation of the domain. And also, I'd like to make it possible that we guaranteed for the tolerance. So even if the post feature dies, wait a minute. Yeah, so even if the, sorry, comment fetching feature dies, users should be able to comment still then. Yeah. Because in the end later, the video can be played by many users and they'd like to read the real-time reaction of the users. So I'd like to separate the services in the backend for fault tolerance. Okay. So firstly, I will talk about the create comment API. So we need the post create service. So the request is routed into post create service, and it should save it in the database. So I create the post database. So I'd like to go with DynamoDB, considering that this database should be quite large. So I typically use the PostgreSQL because it is the industry standard as de facto standard. But Here, I can imagine that the number of command becomes huge, and in the end, if I use the PostgreSQL, I have to do the sharding. And the sharding logic is quite complicated in some cases because application layer has to do the calculation of the shard, and also if there is a spike, we have to reshard the database or something. So that's something quite annoying to do. So I intentionally use the DynamoDB here because in DynamoDB, if we specify the partition key in a correct way, this internally does the scale out. So according to the partition key, it does the consistent hashing. So and also DynamoDB makes sure that the node. Okay, sorry. So, I mean, yeah, DynamoDB can. Oh, I mean, as long as we specify the partition key, so that partition doesn't have so much data, we don't have to think of the capacity of each partition. So I use DynamoDB here, and this post create service creates the post record. Post should be text and user ID and timestamp. And I have to make sure that there is a user table needed. And oh, one more thing. DynamoDB isn't good at doing the sharding. No, sorry, join query. But in a use case, typically in the this write comments per users, I mean, showing the list of users comment is quite rare case. And also, even if I use that, I can do search, create the secondary index of the user ID, and it can be handled. So I would say I don't imagine that there should be many complicated join queries in this post record table. So I would go with the DynamoDB. That's another reason. Okay, so for the post creation, oh, of course, video ID. Okay, and when I use the DynamoDB, I have to make sure the database schema, especially index, is based on the what should I say? Query based schema, query based design. So yeah, I would say query driven design. The query driven schema design. That's what I need in DynamoDB. So I will think of the use case. So when user creates the post, I have to think in which use case this should be accessed and add the index. I mean partition key and sort key. So I will talk about it soon later. So I will talk about the third one, bulk fetch command, because this should be much simpler. So when the user enters opens the video, what is it? So this is post read service. Okay, so maybe it's just a credit request. So I can do it here, post CRUD service. And now what it does is the post should be fetched, the past, comment should be fetched and returned. So now there is a read query. So based on this, I put the index here. So obviously the partition key is video ID because the user is interested in only the video he opened. So I mean the post, I should say comment. Yeah, comment of the video which he opened. So it makes sense to add the partition key with video ID. And for stored key, I'd like to go with the posted at timestamp because typically the comment should be sorted by the timestamp. But the problem here is I have to make sure that the combination of partition key and sorted key must be unique. So if there is a time collision between posted at, the creation of the comment fails. And in a use case, I can imagine that there are intensive writes of the comment for the popular videos, so I want to avoid it. So what I can do is create the sort key column, which should be defined as times posted at and comment ID. In this way, each, this value becomes unique, so I can use it as a sort key, and because of the prefix posted ID, comment are now sorted by the posted at timestamp. Okay, so with this, bulk fetch comment API works, and the query performance is good because I have the partition in the video ID. Now I will talk about the most important and interesting one, fetch real-time comment API. So as I said, I will use the WebSocket here. No, sorry, server-side event here. So what I can do is, let's say here I create the real-time comment API. And reader should subscribe this. Sorry, I mean, so HTTP connection should be kept here. So now user is kind of subscribing the data from real-time comment service. And now the problem is how this real-time comment service can return the data to read user. So one single approach here I can use is making the query to database. But if I do that, the same problem I discussed occurs. Now this real-time comment service has to make the DB query every 200 seconds. And this overloads the database. So this doesn't work. So instead of this, what I can do is when the user creates a post, it should, on this server sends a message to the readers through HTTP SSE connection. So what happens now is the bulk poster and reader, so this becomes the real-time comment service. So, and this should be this comment action, and this should be past comment service. So I put it a little bit, but this is normal HTTP stateless request, and this fetches it. We go. And for here, this real-time comment service creates the record in the comment table, but at the same time, this directory sends the message to the reader users by SSE connection kept here. So this real-time comment service does is firstly create the record in the comment table and then sends the comment to each reader. So what I need to do is this real-time comment service has to know which readers are interested in that comment, which means interested in that video. So what I can do is here we have the mapping video ID to SSE connection. Restart the SSE connection here. So this is in memory. And here I assume that there is only one real-time comment service server. Otherwise, even if when the comment is done, the reader user who's interested in that comment may be connected to another server, physical server. So that's a problem. But I will talk about it later when I discuss the scalability. For now, this real-time comment service is only a single server. So this poster user creates the record here. I would go make this first. So that comment is never lost if anything happens with SSE connection. So here, this is record is created, and then look up SSE from this mapping, and then send back the command to the reader user. So this occurs number 3. Yeah. So what if this number 2 or number 3 fails? In that case, this reader user cannot fetch the messages are not sent to this reader user. So in that case, this reader user, the client should make the request to pass comment service and fetches the missing messages. So I can use a kind of reconciliation or just a fallback on this client. Yeah, so in that way, even if number 2 or number 3 fails, the messages are a bit late, but still rendered in the front end. And I think this is much easier than I guarantee the atomicity of number 1 to number 3 operations. Yeah. So that's how I would, approach this problem. Okay, so now I've met all the function requirements. So user can post the comment in this way. And also user can view comment in real time because when the comment is made, this real-time comment service sends the message to the reader users, all the reader users by SSA connection. And also for functional requirement number 3, user can view comment before he opens the video. This is possible, but because when reader user opens the video, it makes a request of the bulk fetch API, and it is handled by pass comment service, and it bulk fetches the recorded comment records and returns it to the user. Of course, there is a pagination. So as I said, cursor represents the. I can actually say this cursor is now the salt key. So I can specify the salt key here. Yeah. So maybe this cursor is next sort key, sort key after, no, before. So as the cursor, we can specify the sort key of the first message or this message. So with that, from the next request, in the next request to fetch the past comment, the query should be sort key less than cursor, which is the oldest sort key in the last one. So now comments before that are fetched, and because of the sort key, it should be accessed with login time, so it should be fast. Okay, so now, as I said, I meet all the functional requirements. So in the next video, I will talk about the non-functional requirement. Especially, I will talk about the scalability. Yeah. So, of course, if there are many users, I think the most important thing is this real-time comment service should be scaled out to multiple servers. In that case, this mapping of SSE doesn't work in this way. So I will talk and discuss how I can handle that. Okay, that being said, I finished my today's system design practice. Thank you so much. Bye.